Okay guys, so we're looking at simple harmonic motion of a pendulum today. The first thing I want you to do is print off this page from this assignment and add it in to your simple harmonic motion notes. The first thing to note is that a pendulum will only act in simple harmonic motion when we have a really small angle. Usually an angle of less than 5 degrees. I'm going to make this a bit bigger so it's easier for you to see. But in an exam, a pendulum will only move in simple harmonic motions for a small swing. This is because we don't want friction. The more friction we have, the more the object slows down, and therefore the acceleration will not be proportional to the displacement from a fixed point. The object will not be in simple harmonic motion. When an object is in simple harmonic motion, as it is for this pendulum, the period is the time it takes the object to go from one extreme end to the other and back again. Let's trace it. So the period is the time for this full oscillation. It's given by a capital T. So the period of a pendulum is dependent on the length of the pendulum. Let's have a look and check this out. So I have two pendulums here, and I have them at different lengths. Let's put this in slow motion. I'm going to pull both pendulums back so that they swing and start at the same time from the same place. Let's have a look at C, what happens to the period, the time it takes the pendulum to reach the extreme end and back again. Can you see what's happening? We can clearly see in this diagram the pendulum 1 wins. That means the period of pendulum 1 is much smaller than the period of pendulum 2. i.e., the period is dependent on the length of the string. Let's put this into write this relationship as an equation. So the period of motion of a pendulum is given by the formula T is equal to 2 pi times the square root of L over G, where T is the period of the pendulum, L is the length of string, and G is our acceleration due to gravity. Now it's important to note that a pendulum will only be in simple harmonic motion if it's swinging through small angles, so angles that are roughly... Okay, let's look at an example question. This is exercise 13.3. Let's look at question 2. In question 2, we're told that a simple pendulum has a length of 0.8 meters and it makes 50 oscillations in 90 seconds. What is the value of acceleration at this location? So in this case, we are asked for our acceleration due to gravity. To find our acceleration due to gravity, we need our equation for the period of a pendulum. This is T is equal to 2 pi times the square root of L over G. We're looking for G, so I need to substitute in what I know. At this point, I only know my value L. That means that T is equal to 2 pi times the square root of 0.8 over G. So I can see here that I need to find my period before I can find my acceleration due to gravity. Remember that the period is just the time taken for one oscillation. We're told in the question that 50 oscillations is equal to 90 seconds. That means that one oscillation, the time for one oscillation, is equal to 90 seconds divided by 50. So the time for one oscillation is 90 divided by 50. Our period is equal to 1.8 seconds. Let's substitute this into our equation and solve for g. 1.8 is equal to 2 pi times the square root of 0.8 all over g. Okay, when I'm solving for g here, I want g on its own. That means I want g on one side of the equation and everything else on the other. The first thing I'm going to do here is divide both sides by 2 pi to move the 2 pi to the opposite side. This means that 1.8 over 2 pi is equal to the square root of 0.8 divided by g. To solve for g, I need to get rid of my square root. To move the square root, I square both sides of my equation. This gives me 0.8 over g is equal to 1.8 over 2 pi squared. I now need to find g on my own, so I'm going to cross multiply. This gives us g times 1.8 over 2 pi squared equals 0.8. To solve for g on its own, we divide out the values that are attached. So we divide both sides by 1.8 over 2 pi squared. Okay, I now have g on one side of my equation and everything else on the other. To find my final answer, I substitute the values that I have here into my calculator. That's 0.8 divided by 1.8 all over 2 pi squared. This gives me a value of g of 9.75, rounding to 2 decimal places, meters per second squared. Okay, so using your equation, t is equal to 2 pi times the square root of L over g. I want you to solve question 1 and question 3. Okay guys, I now want you to turn to page 8 of your simple harmonic motion notes and look at challenge 4. Please complete challenge 4.